So I'm speaking actually a little bit from two perspectives today. I am the project lead and I am with Environment and Sustainable Resource Development, which kind of initiated this project. But the project is actually a multi-stakeholder project, collaborative, voluntary, with an implementing focus that we as a group will implement this plan. If you know the International Association for Public Participation spectrum, we're at the far right end of that spectrum, which is the collaboration. We truly want to collaborate with our stakeholders in this reach that we have determined has some issues with phosphorus to plan and also to implement the plan together. So on the one hand, we have a plan, and on the other we have a prototype. For Alberta Environment and Sustainable Resource Development, this is an internal prototype to demonstrate how we might implement a cumulative effects management system. There are other similar sorts of prototypes happening in other parts of the department. One of them is the Industrial Heartland project in the northern region, which has been going for about 5 years now. And that one came about because objectives were being exceeded in both air and water quality in the area of the Industrial Heartland. And industry was invited, in quotes, to come together to determine how they were going to address those exceedances and to work together to do that with the support of Alberta Environment and Sustainable Resource Development. In Central Region, the ESRD office has actually organized learning labs where the staff are looking at the various phases of an adaptive management process and bringing in people who are at some stage or other of that to share their learnings so that we can learn better how to implement a cumulative effects management process. In a sense, this is the Cadillac version of the prototype. It's the first one we've done in the southern region, and we've been able to access a number of resources, staff resources internally, and fantastic participation from external stakeholders so that we can try a number of tools in this prototype. And we're gathering lessons learned so that as we move forward, we can find the critical path. What is the simplest way to get from A to B? So some of you will remember the old Family Circus cartoon. Remember in the newspaper, the circle, and it was the family circus. And there was little Billy who would be at the next door neighbor's house playing, and his mother would say, you need to be home by such and such a time. So little Billy would leave his house and he would go wandering all over the neighborhood. He'd go through the doghouse next door, he'd stop and splash in a mud puddle, and he'd check out some plants in the backyard, and eventually he'd get home. There'd be this dotted line showing how he got there. And his mother would say, what took you so long? Well, I came straight home. Well, I kind of feel like the Bow Phosphorus Management Plan is a little like Billy. We're kind of wandering all over the place as we find the right tools and strategies and critical path to how to implement a cumulative effects prototype. And we're looking at that. We're looking at the lessons that we're learning as we go so that we can narrow it down from the Cadillac version to the Toyota version, put it that way. So in the case of the Bow River Phosphorus Management Plan, those of you who were in the previous presentation with Rob Wolf, you'll recall that he talked about how the BRBC developed water quality objectives for various reaches of the Bow River. This is a very, very good example of how WPACs can inform and influence government policy. As a WPAC, as an advisory council, the BRBC took what were the Canadian guidelines and the provincial guidelines, and then, as Rob said, they narrowed them down to what would be the best for the various reaches of the Bow, given that it's a specific watershed, and that in the upper reaches of that watershed, you know, it's cold, clear water, and then later there's more nutrients and so on down through the reach. So you have different water quality objectives for different points of that. They recommended those objectives to the Alberta government, and the Alberta government accepted them. So on occasion over the last number of years, phosphorus levels have been exceeded in some of the reaches of the Bow, particularly in the area around Calgary. So phosphorus, of course, is an important, in fact, essential element. All of us are made up of a certain amount of phosphorus. All plants and animals contain a certain amount of phosphorus, but you can have too much of a good thing. We are in the very upper reaches of the Lake Winnipeg watershed, as you can see on this map. We don't often think about that. You know, the Bow River is actually a tributary of the South Saskatchewan River, which meets up with the North Saskatchewan River in Saskatchewan, eventually flows into Lake Winnipeg and then onto the Hudson's Bay. So even though our phosphorus levels may not be huge at this point, very early in that watershed, it's a cumulative impact. You get the Bow River, you get the South and North Saskatchewan, you get the rivers coming up from North Dakota into Manitoba, all draining into Lake Winnipeg, and all of us know what the impacts of that have been. So the picture on the left is, well, both of these pictures are pictures of green algae and then macrophytes. The macrophytes on the right-hand side, photo taken in the Bow River Basin. So phosphorus, of course, is used in fertilizers, it's used on golf courses, and each one of us eliminates phosphorus every day of our lives. It goes through the wastewater treatment plants, and too much of it can be a bad thing. So we start with aquatic plants, which grow in and around water bodies. In the presence of sunlight and nutrients, the plants will grow and produce oxygen through photosynthesis. Turbulence in the water also increases the oxygen in the water. Organisms in the water uptake the oxygen through respiration. So here we've got our fish here. Now it's a good balance, but Calgary has 3 wastewater treatment plants that add nutrients to the river. And these nutrients encourage plant growth, which increases photosynthesis and oxygen production. It's all good, but at night, these plants do not produce oxygen anymore, but use it up through respiration. The nutrients also have an oxygen demand to change into different chemical species. These further reduce the dissolved oxygen in the river, and if the concentration is too low, the fish will die. Interestingly enough, I just heard this week that when Banff improved their wastewater treatment plant, they got complaints from recreational fishers just downstream from Banff because the fish weren't as big anymore, because the phosphorus wasn't allowing as much plant growth. So what is the Phosphorus Management Plan? It's stakeholders volunteering to manage phosphorus together. It's a very new approach for government. We heard several presentations yesterday, and you're starting to see some themes running through here. But normally, Alberta Environment and Sustainable Resource Development, through its direct relationships with the public, is a regulatory organization. We regulate end of pipe, either in wastewater treatment plants or smokestacks or whatever, and we have approvals for that. But we really don't regulate non-point source, at least not very much. Some other departments may to some extent. They may regulate, confined feeding operations or so on and so forth. But what do you do when you're only really regulating what's actually in the water? Well, it's not cumulative. It's not dealing with all of the other things in the watershed. And again, here is where WPACs provide an incredible support to the work that government is doing. Because WPACs, they know what cumulative effects management's about. They've known from the very inception, because they're dealing with both the land and the water and the air. Well, maybe not the air so much yet, but hopefully that might come in eventually as well. But they know the relationship between the forests and farming and ranching and whatever else and the water. And so we as government need to figure out ways that we can bring all that together. Hopefully not in a mandatory regulatory fashion. If we can bring people together to volunteer to make the differences that are needed, that's the best approach, and we'd rather not use the heavy hand. So this is a photo of the stakeholders, or the steering committee rather, for the Bow Phosphorus Management Plan. Later on I'll show you the various sectors that are involved, but a number of people that are on the steering committee have actually been here at this conference. Just to name a few: Mark Bennett from the BRBC, Lita Van Duyn from ALIDP. I saw Richard Phillips here yesterday from the Bow River Irrigation District, Margaret Beeston from the City of Calgary. And we have right now 17 organizations, municipalities, volunteer, nonprofit organizations, etc., represented, and they are the steering committee, which meets monthly. So how does the Phosphorus Management Plan link with other planning initiatives? Well, we have the Alberta Land Use Framework, under which regional plans, the Alberta Land Stewardship Act actually is the act which allows the creation of regional plans. We've talked about LARP and how it's already been finished. SSRP, you know, a lot of you don't know this, but it actually started around 2002 it was called the Southern Alberta Regional Strategy. But if you think of the acronym, it's SARS, so the name was changed. And it was strictly an environmental approach. And then when the province decided they'd like to have regional plans for all areas, SARS and then SAS and then SAL and so on, gradually morphed into the South Saskatchewan Regional Plan. So we have Alberta Land Use Framework, we have the South Saskatchewan Regional Plan, and then within the regional plans, again as Rob was mentioning earlier, we have management frameworks. And in the southern region, those management frameworks, the one that exists, or the two that exist, three actually, the three that exist so far, one already existed, and that's the South Saskatchewan River Basin Water Management Plan. That existed before land use planning. That's the one that closed the river basin to new allocations, except for the Red Deer River. Then we now have a draft surface water quality management framework. And interestingly enough, that surface water quality management framework derived the objectives, the water quality objectives for the Bow, mainly from the Bow River Basin Council. They've made a few little tweaks and so on, but basically they have adopted what the BRBC did. So therefore, the Bow Basin Watershed Management Plan, Phase 1, that Rob spoke about in the previous talk, is what this is based upon. And now we can also say that it's based on the draft surface water quality management framework. For your information, the other ones that will be coming will be an air quality management framework. There's already a PM and ozone management framework for the city of Calgary because of exceedances in those areas, and there will be a groundwater management framework as well. So what do regional plans and water quality frameworks do to help us understand when we have a problem? So in level one is water quality that is within mean and peak historical values. So approval and license conditions are being implemented, and water, wastewater, and aquatic ecosystem policy is being applied. We're not saying that level 1 is necessarily pristine, because we know we've had 100 years of development or more. But we're saying, you know, this is a healthy watershed if it's at level 1. Level 2 is when there have been occasional exceedances of water quality triggers. So in the case of this project, some exceedances of phosphorus. At this point, it's a warning. Here's the warning bell. We're still okay. We're still within the parameters that we want to be. We haven't exceeded the water quality objectives on a regular basis, but it's time to start planning for when we do, so we never get there. And then when you hit the limit, which are the limits that are set in the water quality management framework, then there will be some kind of mandatory management action imposed. So why not do something before you reach that point where it's mandatory? So that's where we're at. Now, Alberta Environment, as you know, has been monitoring, and SRD, pardon me, has been monitoring water quality in various sites across the province for a long time. And in this particular, in the Bow River, there are 5 water quality monitoring sites. There's lots more monitoring going on in the Bow River. The city of Calgary has many monitoring stations, and there is some other monitoring as well. But in terms of Alberta Environment, there are 5 monitoring sites, which you can see here. So we're looking mainly at that reach that's marked in red. And that's the area from basically the Bears Paw Dam to Bassano Dam. Here's a map of the reach. It includes the city of Calgary, Airdrie, Strathmore, Okotoks, High River, Turner Valley, and Black Diamond, the rural municipalities of the Ndia Foothills, Rocky View County, Wheatland County, and the Kananaskis Improvement District, the lands of 3 First Nations, the Stoney, the Siksika, and the Tsuut'ina, and also impacts the eastern, western, and Bow River irrigation districts. So it's a large area. It's about 1,248 square kilometers, and the length here is approximately 223 kilometers. Actually, you could say it's a large area. It has turned out to be a much larger area. You know, you try to get place-based, and you find no matter how small an area you kind of try to get down to, there are still lots of issues going on. In this reach, there is a lot of land use pressure, a lot of development here. We have agriculture, irrigation, confined feeding operations, a lot of recreation. We have the city of Calgary. The population of the area is over 1 million now and is expected to grow to 1.65 million people by 2030, with an additional 25,000 people every year for the past 18 years. So there's a lot of phosphorus going into the river system. And that's going to increase. And if we're reaching critical limits now, how are we going to allow for that increase? So we needed to have a management plan, which we are calling a management plan. We were originally going to call it a reduction plan, but we realized that even if we reduce phosphorus in the short term, with more people coming in, they're going to add some. So if we can at least keep it where it is, that's a good goal. And if we can reduce it, even better. Now, I'm not a scientist, and if you ask me questions about this pie chart, I'll try to answer them, but really I've got it here so that you can get some idea of where the phosphorus in this reach comes from. And this is during summer and ice-covered winter. So in the summer, you can see that the wastewater effluent and stormwater add up to about 40% below so between Bearspaw Dam and Carsland Dam. So that would be the city of Calgary, Strathmore, Okotoks, the ones that have the Airdrie, they would be coming in and then down to Carsland Dam. About 18% comes from upstream, 11% from the Elbow River, 2% from Nose Creek, Fish Creek 8%, the Highwood River 21%. We're kind of considering the Highwood River, Nose Creek, Elbow River as point sources coming into the main stem. We know there's lots of non-point stuff happening, but we're recognizing that, since we're looking mainly at the main stem, what is the amount of phosphorus when those tribs enter the main stem? Of course, in the snowmelt season and rainwater season, that's when a lot of phosphorus enters the river. Wastewater treatment plants, it's about the same year round. And then we've got over here the ice covered, so the amount, the concentrations in the winter are much, much higher from wastewater treatment plants because they are the same year round. There aren't the flushings from fields and so on in the winter. You've heard of Sesame Street. So the vision then of the Bow River Phosphorus Management Plan is that phosphorus levels in the Bow will be managed within a range that meets the needs of its stakeholders and provides a healthy aquatic ecosystem. The objectives of the plan are to accommodate future growth and development and meet water quality objectives, to create a plan for collaborative action, accountability, and responsibility for all the stakeholders, both point and non-point, and this is what we call the shared stewardship, that everybody has a responsibility in some way. So that's a social and economic kind of aspect. We're not just looking at the numbers, we're also looking at everybody having a part in the solution. And then to manage actions to develop management actions that will meet social, economic, and environmental outcomes. The plan will include strategies and actions, technical and management tools, monitoring, evaluation and reporting structures, and implementation roles, responsibilities, and timelines. And I like the idea that Rob had about a standing implementation committee, and even though we're not at that stage yet, I think it might be a good idea to set it up earlier rather than later. Who's involved? Well, these are the sectors that are involved. I mentioned to you that we have 17 members of the steering committee, and each member has an alternate. The steering committee meets once a month. The one sector that we so far have not actually had attend our meetings is the First Nations sector. So what are we doing about that? Well, we really want First Nations involvement. Obviously their water regulations and so on are governed more federally than they are locally within the reach, but they are our neighbors and they're involved with this as well. So we've made 2 presentations to the Treaty 7 Management Water Subtable Group. Those have both been very well received. We do have them on our steering committee distribution list, so the people that have been designated, they're consultation coordinators, and they receive all of the notices from the steering committee meetings and so on, so they're aware of what's going on. And I have had some conversations. It's largely a matter of the incredible workload that they have. And also perhaps not a full understanding that this is not a consultation thing, this is a collaborative voluntary kind of thing. So what we're hoping to do is actually go out to each of those 3 First Nations and maybe make a presentation individually to each one of them. Okay, so here's the structure, more or less, of the Phosphorus Management Plan. At the, I hate to say at the center because that's not really what it is, but just to show it as a series of concentric circles, we have the project management team. The project management team is pretty well entirely ESRD staff. Originally we did have a few external people on this as well, but this is a day-to-day, all of the work that needs to be done, getting contracts, planning meetings, logistics for rooms, who's going to be on the steering committee, who's going to be on the task teams, keeping the contact list, millions of little tasks that are really project management oriented, and also some of the facilitation of the task team. So it is pretty much an ESRD team. The steering committee, I've already talked about them, the 17 members so far, and they meet monthly. The stakeholder advisory group is the much larger group of people who over the last 2 years, almost, that this project has been running, have expressed an interest in the project. Either they're outside the reach but want to know what's going on, or they're organizations that just don't have the staff capacity to be on the steering committee on a regular basis, or our social network analysis has identified them as people who want to know what's going on. So the intent is to have regular meetings with the stakeholder advisory group to update them on the progress of the planning. Then we have the public at large, and the public at large has not really been involved yet. They will be in the implementation phase once we start going out to implement the strategies and actions that have been identified in the plan. We have several task teams. The Rural Non-Point Source Task Team, each of the first 3 task teams here, the Rural Non-Point, Urban Non-Point, and Urban Point, are chaired by members of the steering committee. And they have kind of invited people that they know are experts in the field, or we've invited people that we know are experts in the field. And those teams have done yeoman work. It's just been incredible. We struck these task teams sort of last June. They were going to meet for a few months. But when Rob said in his lessons learned, he said, for your first attempt at watershed management planning, pick a topic that is manageable. Well, we thought phosphorus on the bow would be manageable. It's huge, and the task teams have had to grapple with that. I mean, when you think about rural non-point sources of phosphorus, you've got livestock, you've got agriculture, you've got irrigation districts, you've got forestry, you've got roads, just so many different variables and aspects. And you have almost no hard data. So it's been complicated. Then we have the data acquisition and modeling task team, and it's been great because they have, actually there's more data out there than we realized, but it was never brought together in one place. So the data on the water quality monitoring and on phosphorus and so on has all been brought together in a report that's actually just been reviewed. It'll be ready at the end of March for the steering committee to look at their April meeting. And likewise, we've been able to do modeling that has brought our modeling information up to 2011, whereas before it was at 2007, most of it, other than the City of Calgary stormwater. And that's exciting because they're building a brand new model that will test phosphorus on a day-to-day basis from wastewater and stormwater in the City of Calgary, and that'll be on stream in about a year. So it's been a great, somebody yesterday in their presentation said the plan is the process, or the process is the plan, I think they said. And that has been so true in this case, where we've learned so much as we've been going along, and there are so many side benefits. So what will successful implementation look like? Well, hopefully excess phosphorus doesn't reach the water, so we're talking edge of field here to some extent. Water quality is improved for everyone's use. We have strategies and actions that ensure phosphorus levels remain within desired limits, and stakeholders are working together to solve the problem, and that's the key. So right now we actually have a learning contract with someone to do a lessons learned. She's interviewed 20 people, both from the stakeholder group, the steering committee, and the ESRD folks, to figure out what's happened so far and what we can learn from that. We also have a social network analysis pilot project going. Now this is not social media. This is how do networks work. So we started with the steering committee group from a meeting about a year ago, and each of those people was asked if they could identify other people that they worked with that might be interested in phosphorus or other water issues. And then those people were interviewed and they identified others, and you get a rolling snowball. The report is actually on our information center website if you want to look, and it's fascinating because you can start to see where the lines come together and where they don't. where the nodules are. Now, the names aren't there because it's confidential, it's the FOIP stuff, but when you're within it, you kind of know who they are, who these people are that are really making a difference. So, we're hoping to have a draft plan completed by the end of June, and then go out to our constituencies to test it with them, then come back and complete the plan, and then move on to the implementation phase. One of the things that I read recently was, try to tackle more than one thing. Not just phosphorus perhaps, but other things. Well, I'm glad we just tackled phosphorus. But in the end, what if it's a big hoax and we create a better world for nothing? And collaboration is everything.